All right, we're looking at 13.6 double angle identities. So we're going to derive our double angle identities. When we say double angle, we mean 2 times whatever angle we have A. So 2A, sine 2A, cosine 2A, and tangent 2A. So we know we could write sine 2A as sine of A plus A. And then we could use our sum formula for sine from 13.4 and say that this is sine A cosine A plus cosine A sine A. And clearly the order which we multiply in doesn't matter because of the commutative property of multiplication. So these are like terms. And so this is equal to 2 sine A cosine A. And there we go. There's our first formula. All right, cosine 2A. With cosine 2A, we know this is going to be cosine of A plus A. So again, we're going to use the cosine formula. And so we're going to have cosine A minus sine A sine A, which cosine A times cosine A is cosine squared A, minus sine A times sine A is sine squared A. And so there is a formula for cosine of 2A. So now it turns out with cosine, double angle of cosine, we have actually 3 different versions of this. So here's the first. Cosine squared minus sine squared. All right? But using our Pythagorean identities, using that sine squared A plus cosine squared A equals 1, we're going to come up with the second identity. So we could replace cosine squared with 1 minus sine squared. So I can take my formula from version 1 here, and I could say 1 minus sine squared A, that's replacing cosine squared, and then minus another sine squared. And so I get 1 minus 2 sine squared A. So that's a second version of the double angle of cosine. And notice it only has sine, which is kind of interesting. Or I could replace sine squared, going back to version 1 here, I could replace sine squared with 1 minus cosine squared. And so we could say cosine squared A minus 1 minus cosine squared A. Sorry about that. Okay, I distribute the minus sign. Cosine squared A minus 1 plus cosine squared A. And I get 2 cosine squared A minus 1. And that is a third version. Okay, third version of cosine of 2A. So 3 different formulas for that. Finally, tangent of 2A. Tangent of A plus A equals tan A plus tan A, all divided by 1 minus tan A times tan A. So we end up with 2 tan A over 1 minus tan squared A. And that's our formula for the double angle of tangent. Okay, so let's just transfer those to the bottom of the page here. So I've got sine 2A is 2 sine A cosine A. Cosine 2A, 3 versions. Cosine squared minus sine squared. 1 minus 2 sine squared. Or 2 cosine squared minus 1. And finally, tangent of 2A, this one is a ratio 2 tan A over 1 minus tan squared A. Alright, now we're going to use those formulas to simplify these expressions. So what we want to do is match up as well as we can, find which formula matches what we're dealing with here. So 2 sine 45 degrees cosine 45 degrees. Well, that looks very much like the sine of 2A, right? Sine 2A is equal to 2 sine A cosine A. So this is my A value here, 45 degrees. And so this is equal to sine of 2 times 45 degrees, which is sine of 90 degrees, and we know from the unit circle sine of 90 degrees is equal to 1. Notice this particular problem, a lot of times we won't be able to do this, but on this particular problem we could have just used the unit circle values to simplify as is. We could have said 2 times square root 2 over 2 times square root 2 over 2. And so you think this 2 over 1, our denominator is 4, 1 times 2 is 4. Our numerator is 2 times the square root of 4, which is 2 times 2, which is 4 over 4, and so we get 1 there also. Same answer. Alright? Usually that will not be the case, like on number 2. Number 2, not a unit circle value, 25 degrees. 1 minus 2 sine squared, that fits one of the 3 formulas for cosine of 2a. So, if this is my a value, 25 degrees, I'm going to say this equals cosine of 2 times 25 degrees, my a, 2a. And so, that's going to be cosine of 50 degrees. Now, since this is not a unit circle value, we'll just stop right there. That's fine. That's a fine answer, cosine 50 degrees. If it were a unit circle, if it was 45 degrees, or if it was 60 degrees, we'd want to go on and simplify that. But as is, we're good with that. All right. Look at number 3. 4 tangent 150 over 1 minus tan squared 150. This is very close to the tangent formula, but on the tangent formula, it's 2 tangent 150, right? Not 4. Otherwise, this fits exactly where A is going to be 150 degrees. Well, think about this. I could write, instead of 4 tan 150, I could write this as 2 over 1 times 2 tan 150 over 1 minus tan squared 150. And just say 2 over 1 here. So this is like 2 times, and now this is my formula, tangent of 2 times 150. All right? So I've got 2 times tangent 300 degrees. And we know from the unit circle, 300 degrees, that's going to be, the reference angle for that is 60 degrees. And at 60 degrees, tangent's equal to square root of 3. I know that in the fourth quadrant, tangent will be negative. So we have 2 times the negative square root of 3, or negative 2 root 3 will be our final answer there. Okay? And this again was one that we could have done without, I mean, we know what tangent 150 is, but it would have been a whole lot more work than changing it to this double angle. Alright, moving on to number 4. We've got 6 cosine squared x minus 3. Notice this is similar, again, we're similar to one of the cosine double angle formulas, but not exactly the same. But, you know, normally my cosine double angle is 2 cosine squared a minus 1. Well, if I factor out a 3 here, I do have a common factor of 3, and if I factor that out, I do have, except that it's x instead of a, I get exactly my double angle formula, 2 cosine squared x minus 1. So my x is equal to a here. And so we'll say 3 times cosine of 2x. Not much I can do with that since I don't know what x is. So there we go, 3 cosine 2x. Okay, number 5. Once again, not exactly the same, but it's similar, most similar to my sine double angle formula. Sine double angle wants a 2 here instead of an 8, so I'm just going to factor a 4 out of that. I'm going to say 4 times 2 sine x cosine x. Right? 4 times 2 is 8, so that's fine. And now this is exactly my double angle formula where a is x. So 4 times sine of 2x. Okay? And finally, one more. Now this one looks kind of like sine, but it does not have a 2 in front. In fact, it doesn't have any number in front. But it is understood to be a 1 here. So if I want 2 sine of 3 theta cosine 3 theta instead of just 1 sine 3 theta cosine 3 theta, well, I can multiply that 2 times 1/2. 1/2 times 2 will give me 1. And now the part in the parentheses fits the pattern I want. So this is 1/2 times sine of 2 times 3 theta. Well, 2 times 3 theta will be 6 theta. And so our answer is 1/2 of sine 6 theta. Okay, same idea on number 7 as the last one. This looks like sine 2 theta, except I don't have a 2 in front. If we were in class, I would be saying, why don't y'all try this one? But since we're not in class, here we go. I'm going to say 1/2 times 2, sine 15 degrees, cosine 15 degrees. Okay, 1/2 times 2 gives me that understood 1 in front here. Now the part in the parentheses is going to be sine of 2 times 15 degrees. Well, 2 times 15 degrees is 30 degrees. So now I've got sine of 30 degrees, and that is a unit circle value. Sine of 30 degrees is 1/2. So we've got 1/2 times 1/2, which is 1/4. And there we go. All right. Look at number 8. This looks kind of like it might be related to our cosine double angle formula, but remember we have other things with sine squared besides our cosine double angle, and that is we've got the Pythagorean identities. Pythagorean identities, remember, said sine squared x plus cosine squared x equals 1. And so this is more similar to the old Pythagorean identity we've been doing for quite a while now, in fact almost all semester. Okay, so I'm going to replace my sine squared with 1 minus cosine squared. Okay, so this is going to be 1 minus cosine squared x minus 1. My 1's now a positive 1 and a minus 1 cancel, and I'm left with negative cosine squared x. And that's about all we can do with that. This is not a double angle situation. This is simply using your Pythagorean identity. So be careful. Don't get in that trap of always thinking it's going to be double angle. There's other stuff out there as well. Okay, last problem. Use the information given about the angle to find the exact value of sine of 2 theta and cosine 2 theta. So we've got tangent theta is equal to -3, and theta is between pi halves and 3 pi halves. So we're talking about either in quadrant 2 or quadrant 3 when we say between pi halves and 3 pi halves. Quadrant 2 or quadrant 3. But since tangent is negative, we know it must be in quadrant 2. So let's draw this. I have a triangle over here, and I'm going to say tangent theta, which I know is y over x, equals negative, and I'm going to say 3 over 1. So my x value, y must be positive in the second quadrant, positive 3, and x must be -1. So here's my -1 and a positive 3. And then if I do x squared plus y squared equals r squared, -1 squared plus 3 squared equals r squared. So r squared equals 9 plus 1, that's 10. And r is always positive, so r is equal to the square root of 10. So here is the square root of 10. This is my theta right here. Okay? So, that tells me that my sine value, sine theta, is equal to 3, do a little bit better there, 3 over root 10. And my cosine value, cosine theta, is equal to -1 over root 10. Now if this were a final answer, I'd want to go on and rationalize that, but it's not. So I'm just going to leave it like this for right now. So let's do A. A is sine of 2 theta. From our formulas, that is 2 sine theta cosine theta. So 2 times my sine theta is 3 over root 10. You can think of this as 2 over 1. Cosine is -1 over root 10. Multiplying the tops, I've got 2 times 3 is 6. Multiplying the bottoms, I've got root 100, which is 10. I've got positive times a negative is a negative, and that reduces to -3/5. So there we go. There's our sine 2 theta. Cosine 2 theta, B, cosine 2 theta. You can use any of the formulas you want, really. You've got 3 choices there. I'm going to use cosine squared minus sine squared. But we would get the same answer if we used one of the other formulas. Cosine squared theta minus sine squared theta. All right. So my cosine squared is negative 1 over root 10 squared minus 3 over root 10 squared. So I'm squaring this negative, it'll become a positive. 1 squared is 1, square root of 10 squared is 10, so 1/10 minus, again the denominator is going to be 10 when I square that square root of 10, but 3 squared is 9. 1 minus 9 is going to be a negative 8 over 10, and again that's going to reduce down to negative 4/5. And so we can see both sine 2 theta and cosine 2 theta are negative, which tells me if I doubled this angle theta, it's going to put me into the third quadrant. It's going to put me in the third quadrant since both sine and cosine are negative. Okay? That's it. If you have questions, let me know. I hope everything's going well. I hope you're all healthy and happy. And I miss you guys, and we'll talk to you soon. Bye-bye.